So now let's find the surface area of a pyramid. And you can see I have my flat pyramid right here. When we fold it up, get a pyramid. And I'm actually going to draw it on this piece of paper, but I'm going to draw it a little bit differently. It'll help us see a couple of things. So here we have our pyramid flattened out, and this one I'm going to be using a square pyramid, and this part right here is going to be the length of one of these edges, lowercase b, and then this part right here is going to be our slant length, L. And we can see that when we fold it up, that corresponds to this part right here. This triangle is this part, and this is the slant length, and it is not the same as this part right here. All right, so here we've got this, and we need to find the total surface area. So the surface area is the lateral area plus, I'm going to do the base in a different color, the base. All right, so to find the lateral area is the area of these four triangles right here. It's the same thing as this part right here, because we see when we fold it up that it's the sum of each of the faces of the triangle. And because we have a square or a regular polygon right here, each of these triangles is going to have the same area. So let's start with that. We know that the area of a triangle is 1/2 the base times height. But here we have b and the slant length. So we're going to use 1/2 times little b, the side of the length of one edge, times the slant length. And we have four triangles right here, so times 4. And this is just the lateral area right here. So we have 1/2 base times height, and our height is L, and b is the edge. And we have four triangles, so we're going to multiply it by 4, and then we're going to add the base. And for our case, this is a square, so the area of a square is just one side squared. So the lateral area is this part, and this is the base. All right, we can rewrite this part to show something else. We know that 4 times the base is actually the perimeter, because it's 1, 2, 3, 4. 4 times the base is the perimeter. So I'm going to rewrite this and say 1/2, 4 times the base times the perimeter times the slant length plus the length of one edge squared. And if we take out this b squared and just write big B for the base, the same thing as I had it up here, we get the general formula for the surface area of a pyramid is 1/2 times the perimeter of the base times the slant length plus the sum plus the area of the base. So for example, we know this is the same for all regular pyramids, so I'll go ahead and draw one with a pentagon as the base, just to show that no matter how many sides you have, it's always going to be the same formula, as long as your B changes for whatever polygon you have. So we have the surface area equals the lateral area plus the base. And our lateral area is the sum of all these triangles, right? And this is still the slant length, and we'll still call one of these edges B. So the area of a triangle is 1/2 base, which is our little b, times the height, which is the slant length. And since we have 1, 2, 3, 4, 5 triangles here, we're going to multiply by 5 and then add the area of the base. And again, 5 times the base is the same as the perimeter, so 1/2 times P times L plus the base. So this part for the lateral area is always going to be the same. That's why I wrote the base in a different color. This 1/2 P times L is always going to be your lateral area. Your base, however, is going to change depending on the type of pyramid that you have. So here we have a square, so the base is going to be b squared. Over here, we have a regular pentagon, so we'd have to use the area for a regular pentagon, or regular, polygon formula, which was 1/2 perimeter, or AP over 2. 1/2 the apothem times the perimeter. Apothem times the perimeter. And that's what we need to find here. And we need to be given the apothem and be able to figure it out. Now that we know how to find the surface area, let's try a couple of examples. We'll start off with a square pyramid. Alright, so here we've got our pyramid, and we'll say that this base right here is 6, and we'll say the height of this pyramid, which runs down to right here, is 18. Alright, so we know the height of this pyramid, and we know this base length right here. So we just found out the surface area is the lateral area plus the base, which for a pyramid is going to be 1/2 the perimeter of the base times the slant length plus the base. And for us, this is a square, so the area of this base is going to be one of these side lengths squared. I'm going to call that side length little b squared. Alright, so we need the perimeter of the base and the slant length. We have one of these sides, and we know the perimeter of a square is going to be one of these sides times 4, because 1, 2, 3, 4. So the perimeter is 6 times 4, which is 24. So we have the perimeter. Now we need the slant length and the area of the base. Let's go ahead and do the area of the base first, because that one's easy. Again, area of a square is going to be one of these side lengths squared. So 6 squared is 36. And now I need the slant length. But they didn't give us the slant length. They only gave us the height. But just like we had with a cone, what we have right here with the height and this part of the square right here and the slant length is a right triangle. And I'll redraw it over here. No, it doesn't look like a right triangle, but it is one right here. This part right here corresponds with this part right here, and that's going to be 1/2 of one side. So 6 divided by 2 is 3, and they gave us that the height is 18. So we're going to use the Pythagorean theorem to find the slant length, and it's going to be 18 squared plus 3 squared. And that's going to give us, got my calculator here, 18 squared plus 3 squared is 333. So the square root of 333 is our slant length. Square root of 333. And now we just need to plug into our formula. So 1/2 times p, 24, times L, square root of 333 plus area of our base, 36. That gives us 24 divided by 2 is 12 times the square root of 333 plus 36 units squared. And that's our answer. Alright, now let's try it for something a little bit more complicated. Alright, for our next example, we're going to be using a pentagonal pyramid, a regular pentagonal pyramid. So our base is a regular pentagon with a side length of 8, and our slant height right here, I know it's hard to see this is the slant height, is 20. They gave us a slant height of 20. So again, we're going to write out our formula. The surface area is 1/2 PL plus the area of our base. And the area of our base isn't so simple this time because we have a regular pentagon. Alright, but let's start figuring out what we do and don't know. The perimeter is just one side length times how many sides we have, so 8 times 40, or 8 times 5, sorry, is 40. We need to know the area of our base, or actually, that's in blue. The area of our base, which we don't know yet, but we can figure that out, and our slant length is 20, because they told that to us right here. So the area of our base, we have a regular pentagon right here, so we need to use our formula for the area of a regular polygon, which is the apothem times the perimeter divided by 2. So we need to figure out this apothem because we know the perimeter is 40. So to figure out our apothem, we're going to need some trig. And I'll go ahead and redraw this right triangle that we're going to need to make right here. So this right triangle right here, this part right here is going to be 1/2 of the length of one base. So this is 4. This is the apothem that we need, and this is the radius of the pentagon. And we know that this angle, I'm going to draw this part of the triangle. This angle right here, the whole angle, is 360 divided by a number of sides. And that's going to be the case for every regular polygon. It's going to be 360 divided by a number of sides. And I just realized you guys can't see the triangle that I drew down there, so I'm going to redraw it over here. And I'll restate what I said. This part right here is half of this whole edge, and this right here is our apothem. This is what we defined, and this is the radius of the pentagon. And 360 over 5 is always going to be the degree in this whole part. So 360 divided by 5, I believe that's 72. Yes, this whole part is 72 degrees. That's 360 divided by 5. So this part right here, which is only half, is 36 degrees. And now we need trig. So we need to figure out something that relates this opposite angle and this adjacent angle. And to do that, we use tan. So the tangent of 36 is opposite over adjacent, 4 over a. And now we need to get the apothem alone. So I'm going to multiply both sides by a. So we get a tan 36 equals 4. And now I'm going to divide both sides by tan 36. So we get a equals 4 divided by tan 36. And again, at first I multiplied both sides by a. So the a over here, and these ones cancel out. And then I divided both sides by tan 36. So now we know that a is 4 divided by tan 36. So now we just need to plug into our formula. 4 divided by tan 36 times the perimeter, which we figured out is 40, all divided by 2. And I'll go ahead and simplify this for you. 4 times 40 is 160 divided by 2 tan 36. I'm going to keep it in exact. So this is now the area of our base. 160 divided by 2 tan 36. So now we have all that we need, and we're going to plug it in to this formula that we have up here. This should be a big B. I apologize. This is a big B. So we have 1/2 times the perimeter, 40, times the slant length, which they gave to us, 20, plus the area of the base, which we just found out is 160 divided by 2 tan 36. So our final answer is, move this over so you guys can see it better. 40 times 20 is 800. 800 divided by 2 is 400. So we get 400 plus 160 divided by 2 tan 36. And that is our final exact answer for the surface area of this pentagonal pyramid.